Hey guys, I'm back. Today we're going to be doing a video on the law of, the conservation of mass. This is going to be a very, very simple, talk of it. Because this is a very interesting law. It's got some serious implements, and it goes really deep. But we're going to talk on it, about it on a very minor level today. I find this law to be really cool, so I'm going to show you what I mean by that. With my example, we are going to be talking about combustion. Combustion is when I don't know, how do I describe combustion? One of the good example of combustion is a fire. We are combusting something to make it into something new. It uses oxygen and will turn things into oxide. So fire is a major example of this. Let's draw a beautiful fire, okay? Oh yeah. Okay, so I can't draw, we all know that. But that's my fire. Now, what is going on here? I mean, we have the logs, which is something that is burning. But we also know that it's making this flame. Something is happening there. It is outputting gas. It is taking in oxygen. By the time a fire is done, we have some stuff left over. In our nice little fire pit here, we have what's called ashes. Now, if you were to ever look at ashes, you will notice that the actual size of ashes compared to the original log is much, much smaller. Why is that? Because according to the law of the conservation of mass, which is, as I state, that mass cannot be destroyed nor created. So where did it go? Well, to answer that, we're going to look back at our fire. This time I'm just going to draw a fire because I'm not showing those logs again. If we look at our fire, like I've said, a couple things are happening. But there's something else that's happening that some people don't really look at. That's a terrible drawing to show that it's letting out different kinds of gas. Theoretically, if you could put this combustion, whatever's happening, our nice little fire. Oh, my marker's running out. No. If we could put this nice little fire. Oh, jeez. Okay. Into a big balloon or into a good capsule that will capture it. And this balloon is big enough to hold all of the oxygen needed for the fire to keep going. Everything that it needs is in there. And we were just to wait till it burns out by itself. And all we have left in this balloon are, well, what would we have left? We would have left the ashes of the original fire, of all the wood. And then we would have all of this gas. Now, if we could somehow condense this and track all of the mass that's still in here, what's funny is the mass that's inside of the balloon is equal to the mass that was originally in those logs. Meaning, when we relate this back to chemistry, when we have an equation, a chemical equation, like, let's just say, you know what? I'm writing too big. See, I don't know how big I have to write for you to be able to see it. Yeah, that works. No, it doesn't. Yes, it does. Make sure I'm still recording. Sometimes I record these and like it stops recording. Anyway, if we have an equation like this, what this means with this is we can think of this as an equal sign. In actuality, it's taking these and turning it into this with something happening here. Doesn't matter what that is. It could be a number of things. But the point still stands that everything on this side has to be equal on this side. It could turn itself into different compounds, but it has to be equal. Look, let's break this down. What we have in here is we have K, potassium, and we have Cl, which is chloride, question mark. Hang on, wait, chlorine. Now, on this side, and on this side, we have 2 Ks, which means we have 2 potassiums, and there's also 2, right, chlorines. On this side, we also have 2 Ks and 2 Cls, meaning they're equal on both sides. For a chemical reaction to work, it has to be equal on both sides. And that is what the conservation of mass is saying. I will probably make a video when I'm not so busy with exams on the actual implements of conservation of mass, going more into detail of that because I find it really interesting. But that's more for a physics lesson. So that's all I've got on this. Thank you for watching. Rock on and go outside, touch some grass, go look at the stars.